Hello, everyone. Welcome to this next video regarding stoichiometry. In this case, we will talk about the last part that is involving stoichiometry calculations, stoichiometry procedures, and we will talk about limiting reactant. Now, this topic of limiting and excess reactant and how to identify them, we have talked about this previously in class using several examples, using food, and having seen the theoretical portion of that. In this video, my purpose is to focus more in the logic, in the procedure, and how to approach these type of problems, and to identify like how to start and which aspects are important in order to carry on your type of problems, right? So I'm going to skip ahead the theoretical portion of this class, of this presentation. Regardless, you have this material also available in class, so you can consult with it if you have any detail that you want to check out later. So the question regarding, or more specifically regarding this topic at the beginning, is how do you determine it, right? How do you know or identify which one is a limiting reactant, which one is the excess reactant, and what is it for, right? Once I identify it, how is this actually helping, right? So we have talked about the different steps to consider when approaching this type of problems. The first one is to be sure that the chemical equation that you're given is actually balanced. For purposes of our class, of our course, the equations will be already balanced. So you don't have to worry about that, right? At least for the chemical equation. Step two would be if I don't have the moles available in my question, in my problem, then the first step is to change this into moles so we can work with this later, right? So given that we have a problem or a question regarding grams, more commonly being grams, would be to change these grams into moles so we can work with that, right? And the third step is to calculate the mole-mole relationship between the two reactants that I have at the beginning. Remember, this is a previous step before going into the stoichiometry situation, right? This is basically comparing two reactants among them to identify which one is the limiting and which one would be the excess, right? So remember this map that we have talked about before. It's important to have this well identified at all times, because as always, every time that we talk about stoichiometry, this is the path or the procedure that we will follow specifically for changing between grams and moles to grams, right? So the first step, as we have talked about before, is balancing the chemical equation. Again, you don't have to worry about this except for the questions or the problems that require balancing explicitly, right? Like if the instruction is balance the equation, then worry about that, right? But for stoichiometry purposes, this is not going to be the case. The equation that you will be provided will be already balanced, right? This is more about the topic for balancing equations. So now let's see the first example that we are given, right? Or the first situation. It's not yet just an example or a problem, but it's more like to understand what is actually happening, right? Remember in stoichiometry, before we were given usually like a question, right? Like how many moles of any compound, right? Assuming or given that we are given, I don't know, 2.2 moles of something else, right? We can say CO2, right? So we usually have this situation, this type of problems where we have one unknown substance, in this case would be water, and we have one known substance, in this case would be carbon dioxide, right? In limiting reactant is more like a step before that. It's actually providing us two options. right? In here, we have a problem asking us to compare 8 moles of aluminum and 8 moles of chlorine, right? And chlorine gas. So in order to know which one of these is going to be our starting point, right? Assuming we have 8 moles, this would be the same, right? 8 moles of aluminum or 8 moles of chlorine, right? So with this information, we're going to start our future problem, right? In the next stage of our problem, because at the end, the problem is going to ask us, okay, so how many, I don't know, grams, let's say, how many grams of aluminum chloride, right? So that would be one type of problem, right? Where we are provided with two different quantities or two different amounts, and they're not gonna simply, or not most cases, they're not gonna say, okay, first give me the limiting reactant. It's just gonna jump straight ahead into telling me, okay, you have these two options. How many grams are you gonna get of this one, right? So that instinct is, okay, I have to use these two things simultaneously or in some way fit them in a formula to find out the result. But in reality, this is actually asking us to determine first which of these two situations is going to be our limiting reactant. So once we have established it, we can eliminate one of these and use the limiting reactant for our process, right? So following here, like it's always important to consider if I have the balance equation, which will be yes. If I need to convert reactants to moles, in this case, moles are already given, so I don't have to change anything, right? I don't have to change from molecules to moles or from grams to moles. It's straightforward, moles already being provided. And the last one is basically now do the process, right? Find the relationship between them so we can analyze the data that we have in paper and make a decision. So what does this mean, or what's the purpose of this, right? So imagine that you're working in a lab, right? And you have these two options, right? You're trying to follow a formula that has already been given. And at the end, probably according to the situation, you're going to be asked about how much of the product can you actually make, assuming that you have different options, A and B. And you have different, well, in this case, it's the same, right? So you have option A and option B, right? So the problem or the question is which one of these is going to run out faster or is going to be the first one to actually finish? And this question actually arises from the fact that if you make this, let's say, without prior knowledge of which one is going to run out first, well, you might actually find yourself wasting material, right? Needlessly. So let's see in here. So let's see the question in here. It says, if you have 8 moles of aluminum and 8 moles of chlorine, which one is a limiting reactant? So this is like the first step, right? On identifying, so we can later work in stoichiometry, right? So the fact of this one actually comes that if we use the 8 moles that we're given, let's say we use the 8 moles of aluminum, then we would require, according to our ratio that we have in the formula, we would require a specific amount of chlorine. But at this point, I'm not really sure if I'm going to be able to afford it or to have enough in my stash of chlorine, right? Because the ratios that we need are different for each, right? And the different scenario is what happens if I use my entire stash of chlorine. Will I have enough aluminum to actually make this entire equation happen, right? So let's see how are we going to approach this, right? Because at the end, the idea is that you follow the most effective, cost-effective process to accomplish this specific task that you're required to do in the lab, right? So it's important to mention or to identify that these moles that we're given, right, these first quantities that we're provided is kind of like saying you have this in the lab, right? You have two beakers or two containers, right? Two containers that have this amount. Are you going to be needing more or is this enough? And if you need more, then let's assume that you cannot get more. So which one of these is the one that is going to be functional for our specific task today, right? So let's try first in theory so we can later use it in practice, right? So what we are going to be needing to do first is ignore a little bit the product just for a while, right? Because we're going to be discussing between the two reactants and finding out the relationship between them. Imagine this is a fight and one of them is going to win, right? So let's start with the first scenario. Let's hypothesize. Let's make an assumption, right? If I use the entire stash of aluminum, then I would be requiring 12 moles of chlorine, right? What I'm doing here is finding the ratio according to my formula. Remember, these numbers that I have in the ratio, they come from my formula, right? Because we're trying to keep the same ratio according to my chemical formula to find out how much would I be needing at the end of the opposite reactant, right? Of the counterpart. So this is scenario one. If I use my entire stash of aluminum, then I will be needing 12 moles of chlorine, right? Okay, write it down, right? Keep it on one side. So I have to question this. Do I have this available in my lab? Do I have 12 moles of chlorine standing back there in my table? So how do I know this? Well, you can actually compare, right? These 12 moles of chlorine, do I have them in my stash, in my laboratory stash? Actually, I don't, right? I only have 8. So if I use my entire aluminum, chlorine is not going to be enough. I need to buy more, right? So maybe this is not the best idea, right? Let's see scenario 2. What happens now if I use my entire stash of chlorine? So we find the ratio according to a chemical formula. And after my calculation, I will find out that I will need 5.33 moles of aluminum, right? What about this? Do I have this amount stashed in my lab, in my table? Do I have it? Well, if I need 5.33 moles of aluminum, I can compare with my original amount, and I will find out that what I need is actually less than what I have, right? Which means, yeah, I can do it. I can use my entire stash of chlorine, and I will have enough of aluminum to actually maximize the amount of product I can make, right? So this means what, right? That my limiting reactant is going to be chlorine, because chlorine is going to run out first, right? If I use all my entire aluminum, it's not going to be enough, right? So chlorine is going to be my limiting reactant, right? And aluminum that I have more than enough, right? In case I use chlorine to actually continue with my process, I will have more than enough. Even it's going to be some reminder there, right? So aluminum will become my excess reactant, right? All right. Now, let's see another example with grams. Now, with grams always comes an extra step, remember, because we need the molar mass, right? So this problem will be presenting you with also two amounts, two quantities, right? One for aluminum and one for chlorine, and they're presented in grams, which means we need to follow the steps, right? And we will find out that the first step will balance the equation. But after this, we need to convert this into moles first. We cannot work with grams to find out the limiting reactant. We first need to change it to moles so we can find the ratio, right? According to our chemical formula. And for that, we need the molar mass, right? So with the molar mass, now we can continue and find the ratio or the relationship between these two. All right, so first step, find the molar mass. What is the molar mass of aluminum? Well, we can check the periodic table and we will find out that it's 27. Same story for chlorine. We'll find out the molar mass for chlorine, which we'll find out that it is 35.45. So we can stay in 35 and use that molar mass. Since we have two of chlorine in our chemical formula, that means that we need to multiply the molar mass of chlorine times the 2 that we have here, right? Therefore, we will have a total molar mass of 70 for this particular chlorine, right? Okay, so now that we have the molar mass, write it down in one side and keep it for later, right? All right, so now we need to change this into moles, all right? Now that we have all the information, we can actually change the grams into moles. And we will find out that we have 4.22 moles of aluminum in this particular amount of grams. And for chlorine, we will have a total of 2.65 moles hidden in this amount of grams, right? Now that we have changed this into moles, this is going to be our new starting point or our new starting quantities, right? So we can do the process, the ratio, and compare and reach a conclusion, right? So write these numbers, and now let's bring them to our comparison, to the third step, right? So in our problem where we had grams before, we will now, you can temporarily replace with the amount of moles. And with this, you can work, right? So let's start. In scenario 1, what happens if I have 4.22 moles of aluminum and I want to use them all, right? As a result, I will have 6.33 moles of chlorine, right? So if I use my entire stash of aluminum, I would require 6.33 moles of chlorine. All right, so let's keep that in mind. Let's do scenario number 2. If I use my entire stash of chlorine, how much of aluminum would I need? Well, by doing the ratio, again, using the data from the equation, I'll find out that I will need 1.76 moles of aluminum, right? So now we can compare, right? And analyze, do I have these amounts in my lab? If your answer is yes, then this amount will become your excess, right? If the answer is no, this will become your limiting reactant, right? So let's check it out. If I would need at the end 6.33 moles of chlorine, let's check in our table, right? I have 2.65 only. So I will not be able to do my process with aluminum, right? So that means that chlorine, because it's going to be running out, chlorine will be my limiting reactant, right? Let's compare the other one. If I use my entire stash of chlorine, I would require 1.76 moles of aluminum. Do I have this amount in my stash? Yeah, I have more than what I need. And I will even have an excess after I finish my chemical equation, right? Or my process. So that means that aluminum is going to be my excess reactant, right? Once we define which one is the limiting reactant, you can continue to the second stage of your problem to find out whatever it is that they're asking, right? Now, we can organize this in several ways. One is with this, right? And you can just compare and contrast, right? But we can also use this information in different, to organize it in different ways. Whichever works for you best, it's good, right? But it's important that you have some sort of procedure clearly described into saying, how did you get to that conclusion, right? In this other way is basically you put the information in here that you're provided by the problem and find the ratio and find out that if I use all my entire stash of aluminum, I will need 6.33 moles of chlorine. For scenario 2, I would have the entire stash of chlorine being used and I will require 1.76 of aluminum, right? We can compare these numbers, remember, analyze by crossing, right? So if I will need 6.33 moles of chlorine, I can compare to what I already have, and I will say that it's not going to be enough. So chlorine is going to be my limiting reactant, right? Because I will need more than I have available. In the contrary, what about aluminum, right? So you can compare what you will need with what you have available in your lab, right? You will find out that you need less than what you have available. That means that aluminum is your excess reactant, right? Now that you have reached this conclusion, you can choose to work with the amount given or provided by chlorine and continue with the next stage of your problem to find out how many moles, how many grams of aluminum chloride, or whatever it is that you're being asked about, right? You can also organize this in a table, right? So at the beginning, you can put like the amount, you can put the compounds or the elements that you're given and think, how much do I have in my lab, right? These are the amounts that are provided from grams, change it to moles, right? Grams, change it to moles, right? Now, the question is, how much would I need if I use the entire amount of the counterpart, right? Of the opposite or the contrary, right? Of the other reactant. So if I use all my aluminum, I'm gonna need 6.33 moles of chlorine. If I use all my chlorine, I'm going to be needing 1.76 of aluminum, right? And now what you can do is just subtract these numbers, right? From the side of aluminum, you can subtract it. If the subtraction gives you a positive number, that means that this guy is your excess reactant, right? If the difference between the two that you got gives you a negative number, that means is your limiting reactant. With this information, we can conclude that the limiting reactant is going to be chlorine. So it's important that you choose this one to make further problems down in the path for other stoichiometry situation, right? Again, why am I using the limiting reactant instead of the excess? Because since this is the one that is going to be finishing first, this is the one that conditions how much product you will have, right? So now let's have this table compacted in the top side of the screen. And let's analyze which type of questions might actually be related to this, right? Let's see the first one. It says, well, let's read the problem, right? We have the chemical equation just as before. And we have, if I have 114 grams of aluminum reacting with 186 grams of chlorine to form aluminum chloride, then the question is, how many moles of aluminum chloride will be produced? Do you see how the question is not even asking you to take the limiting reactant or the excess reactant or any of that? It's just assuming that you already know how to reach to this conclusion, right? So there's a secret question in here, like secret question, let's say, I don't know, question O or 0 is find out the limiting reactant so you can answer the following questions, right? So by having these two amounts in the problem, it's you need you need to compare between them. You need to like have them fight among them to see which one is going to be the limiting reactant. And the one that turns out to be the limiting reactant is the first quantity or the only quantity that you will consider to answer everything else, right? So if we put this in the same way that we have been organizing the stoichiometry problems, is like, I have 114 grams of aluminum, I have 186 grams of chlorine, and I want to get into moles of aluminum chloride, right? Does this look familiar? You know, you have a known substance, right? Like this one, and you have an unknown substance, which is this one. But in this case, you have two different options for known substances. So you need to define which one you're going to use. In our example, chlorine is the limiting reactant. So this is the one that we're going to be using, right? So for this case, we're going to erase aluminum and we're going to use this as our original quantity or as our original amount. this is going to become our known substance. So now we do stoichiometry. We start from chlorine and get to moles. In this example, we're starting with 186 grams of chlorine. So if we do the map, you will go from grams. So from chlorine, this is going to be our known substance, going to moles of chlorine, crossing the bridge, to moles of aluminum chloride, which is the one that you are being questioned about. And that will be our answer, right? Because we're being asked for moles. Check out the next question. It says, how many grams of aluminum chloride? Well, since in letter A, we were already asked about moles, you can just continue the path into the grams of aluminum chloride, right? What about the last question? It says, how many grams of excess reactant will be left over? This one is trickier because it's not requiring you to know which one is the limiting reactant, but it's expecting you to understand that you need to check about the excess reactant, right? The one that we disregarded at the beginning, right? So it says how many grams of excess reactant will be left over once we finish our formula or our equation or our chemical change using the limiting reactant, right? Assuming that we're using this guy, after we're done with the process, how much of the excess reactant will I have left over and put back into my shelf in the lab, right? So we need to see how much did we begin with, right? How much did I originally have in my container? And how much after we use chlorine, how much did we use, right? This is the amount that we use. So the number that we're going to be using is the answer for this subtraction, right? But remember that these are moles. The question is asking for grams. So once you find the difference between these moles, now you just multiply it by the amount of grams, which is 27, remember the molar mass of aluminum, and we will get the answer for this problem, right? So just for you to have, the answer for the first one is 1.77 moles of aluminum chloride. Once we do the whole path, remember, using this number of our limiting reactant, right? So in this problem, we disregard aluminum. We only use this. We change it to mole, which is already given by us because we worked on this previously. So 2.65 moles of chlorine, we will use our ratio, right? Provided by the formula, right? Which would be, we do the ratio, moles of chlorine in the bottom, which is 3. And on the top, because you want aluminum chloride, you will put mole of aluminum chloride, right? And the number is the 2, right? That will give us 1.77 moles of aluminum chloride. Okay. Now, as we have this amount already provided, and the next question is about grams. So now we need to get the molar mass of this formula so we can multiply by the moles and get the grams that are being produced for this particular substance, right? Which will be 233.64, right? Now, the last one is how many grams of excess reactant. So after we do this whole calculation, right, this subtraction, we'll get the number of moles that are remaining for our excess reactant. We multiply that by the 27, that is the molar mass of aluminum, and we will get that we will have 66.41 grams of aluminum as left over after we're done with the equation, right? After we're done with our process. Again, limiting reactant is the one that you will eventually use, and the excess reactant will be the other one, the counterpart. All right, so these problems, of course, have a lot of different details to be considering, right? It takes a long time to answer one of these because there's many steps for you to consider. and steps that you need to solve before starting, right? So my recommendation is to first start by getting the molar masses of the compounds that you have, then find the limiting reactant, right? In case you have two quantities, you find first the limiting reactant, and then you answer the problems that have to do with stoichiometry as we have studied before. With one known substance, this known substance is going to be the limiting reactant, and the unknown substance, which is the thing that you have in your problem, right? Or in the original question. So try several times. It will take some time. This is like learning a new language. This is like going to the gym. You won't get it at first, but you do one small step after another. And if you trip, pick yourself up, ask for help, and then you continue, right? At the end, practice makes perfect. And this is basically the bottom line of all of this, right? So if you have questions, you can just watch this video again. If you still have questions about stoichiometry, go back to stoichiometry video. And as always, you can send me an email or ask me during class. We will continue to practice this in our class. That's it for now. And I hope this was helpful. I know it's a lot. Take some time to go through this, and I'll see you guys later. Bye.